Okay, so here we're going to have a close-up version of yesterday's lab that I did just because my Zoom meeting, I forgot to change the setting, so you just had this little tiny box that you could barely see anything. The descriptions were all still good, but this will give you a chance to see some of the stuff. So, what I have here is my three corn syrup solutions. I have the dark corn syrup, that's all I had left, so it's the same thing, it just isn't as refined and processed, so it's not clear. So if I put in 1 scoop of salt, which is representing our silica, which is like sand, quartz, silicon dioxide, and in the middle one here, my andesitic lava, I put in 2 scoops of the silica. And then in my last one, my not basaltic, rhyolitic representation here, I put in 3 scoops. Eli, do you want to start stirring the basaltic lava, the one with 1 scoop? Okay. So I put in my 3rd scoop there. Okay, stir this one out, please. Right here, that one's all done. Thank you. Okay, shortly we're gonna compare the viscosity of these lavas once they're stirred up. So viscosity, you might have heard of viscosity with like different kinds of oil. The different kinds of oil you can put in your cars have different viscosities.
Dad, I need
meaning
to do
they're
something.
thicker. What?
I need to do the last thing.
No, I need you to help me quick.
Mom.
Remember the race we're gonna do? You get this one. That's the basaltic lava, Eli. That's the one with 1 scoop of silica or salt. Elena, or Emma, just a minute. I've got the rhyolitic. This was the one with the 3. So for viscosity, high viscosity is going to be thicker and slower moving, where low viscosity is thinner and moves faster. So remember, basaltic is what Eli has. Rhyolitic with 3 scoops is what I have. So remember, we're going to tip on go. On your marks, get set, go. Okay. So we can clearly see, tip more, Eli. More. Like you're going to pour it on the table. Pour it on the table, Eli. Okay, let's do the race the other way, but let's let it sit down. We'll do one more race.
This time we're gonna switch?
Sure, I guess. Okay, so we swapped them here. I have the basaltic, the 1 scoop again. He has the rhyolitic, the 3 scoops.
And then even I
On
had
your
this
marks,
yesterday.
get set, go. Almost tip it, Eli. Tip it on the table. You're not tipping it as much as I am. Okay, but anyway, you can see the basaltic lava is the one that's flowing the fastest here. Okay.
Now blow bubbles.
So it's pretty slow there. Where I can pour this one out much faster.
Dad, now it's just time to
Yes,
blow.
we can blow bubbles now. Okay, so the next part with this lab was to blow bubbles in these ones. So Eli's blowing bubbles in the rhyolitic right now. Okay.
Kind of holy.
So if I do this side by side maybe. Whereas if I try in this one, whoa, I have to put a lot more pressure in the rhyolitic lava. I have to push with more force to get a bubble to form. And then when I do, I like feel this big puff of air coming right up into my face.
Me too.
Really? Is it kind of explosive?
Yeah, the air makes some of it explode onto the table. That's right there.
So when I blow into the basaltic lava here, it's a lot less violent.
That was great.
It doesn't trap the gases that well, and not to discount the kind of in-betweener, the andesitic lava, it's going to be kind of right in between. So it's hard to kind of show the difference in how hard you have to blow to get it to have a bubble form and how explosive it is. I can assure you, by 3 scoops, my rhyolitic lava, I have to put a lot of force into getting it to even make a bubble. And when it finally does release, you've built up so much pressure, so you're using so much force that it's a much more violent bubble popping, which represents a violent volcanic eruption.
Well, we have to blow. Well, the kids blow softly.
Yeah. So we want to be able to describe the differences in viscosity between my 1 scoop, my basaltic, compared to the consistency of my rhyolitic, which is, maybe it's just not sturdy, I don't know. It seems pretty well stirred. Hey.
How can I get back to my
Pretty
job?
slow. Sure, Eli. Thank you for your help. I wish I could do this side by side. Let me see if I can get this held up. Oh, see them both. Okay, the one in my left hand is the basaltic lava. It's definitely winning the overall race. Okay. I guess maybe, well, I'm gonna have to clean up anyway. So let's just pour them on the counter. So you can see the basaltic lava, the one on my left hand, is much runnier and it kind of flows out in a long stream, where the rhyolitic lava is a little bit more clumpy. This is kind of what you're looking at here for how the viscosity of the lava is, how well it flows, and then the bubbles, the blowing bubbles, is how well it traps gas. And then take a look at the notes or the other lab video to hear about a little bit more about like the types of volcanoes, like a cinder cone, a composite, or a shield volcano. What kind forms completely depends on what type of lava you have, whether you have basaltic, the rhyolitic with the most silica, or the andesitic with the kind of in-between amount. Completely determines what kind of volcano is going to form. So let me know if you have any questions. I hope this was a little bit more helpful. I'm trying to do my best showing this lab stuff on a video instead of in person. So have a good week.